This is not always going to be the quickest way, but it's going to be the way that I think most of you resort to if all else, if something doesn't jump out at you right away. The only reason here that this might be something good to do, or why you might think to do this, is because there's nothing other than cotangent and tangent. If there's other trig functions, it's probably a good idea to change everything to sine and cosine. The reason that works is if you look back at those basic identities, there's, for every single one of them, there's a way of changing it to something that involves sine and cosine. Like for cosecant, there's this one, you can change it to 1 over sine. For secant, you can change it to something involving sine or cosine. Tangent, something involving sine or cosine, and this, sine or cosine. The only other one here is this, relating cotangent and tangent. So if all you have in your expression is cotangent and tangent, you might want to try that. Otherwise, you might want to try the other ones. This one might be slightly quicker here. If you take this and change it all to tangent, you have this plus 1. Now the top, there's no fractions involved there, so I'm going to leave it the way it is. I'm not going to do anything with the top. I'm just going to change the bottom. Some of you, I don't know how organized your writing is, but don't leave part of it out and then come back to it later. Like, don't say, okay, here's this, I'm going to write this over here, and then I'll come back and put it in. Rewrite the whole expression and work with it so you don't lose track of anything. That 1 needs to be changed to tangent over tangent. Right? This can become that. And the reason is because then you have a common denominator here. Once you make a common denominator, then you can probably start to cancel some things. 1 plus tangent over, oops, let's write it as one fraction here, 1 plus tangent. And maybe you can see ahead as to what's going to happen here. Again, I think I mentioned to you last time that once you're good at this, it's like being a good chess player. You can see 5 or 6 steps ahead. You know, like if I added those, then I'm going to get 1 plus tangent. Maybe I can cancel it out. Keep track of where the kind of the main division bar is right there. Then if you take this whole thing up here, not that I'm going to have much room, but 1 plus tangent. Okay, that whole thing, and I'm going to need to put brackets around it now. If I multiply this by the reciprocal, dividing by that fraction is the same as multiplying by the reciprocal of that fraction. If you have it as part of a fraction, you don't need to put brackets around that binomial. If you don't have it as part of a fraction, you do, right? So I either need to put brackets around this thing, like that, or some of you I know do this, you put a 1 over top and then you don't need brackets. One or the other, right? Because if you just leave it like this, technically this is not correct, right? If you say multiply, because then it would mean only those things are being multiplied. Now maybe that's a finer point of just how we're writing it right now, but one or the other there. And maybe some of you can see what to do better if there's a 1 underneath like that. If you have those two fractions multiplied, you can't cross off those two individual tangents there because it's part of a binomial. You can only cross off an entire binomial here. But then you're already at tangent theta divided by 1, so you're just at tangent theta. A few less steps there. So maybe that's a little bit quicker. But they both work. So this last one here happens to work, and maybe it doesn't occur to you until you have seen it. But if we have 1 plus tangent over cotangent plus 1, if you go back to that identity that says cotangent theta is 1 over tangent, you can learn these identities a different way as well. If you have something like 0.5 is equal to 1 divided by 2, you could also switch these. You could switch those around, right? And you could say 2 is equal to 1 divided by 0.5. Couldn't you? Can you write it that way? Or what's the third way you could write it? You could write it using multiplication, right? 2 times 0.5 is equal to 1, right? You work with formulas like that all the time. If A is equal to B divided by C, C is equal to B divided by A. Or you could write it as, what's the third way? A times C equals B. What this is for this one is, this could be this tangent. If this was up here, those two things multiply to tangent times cotangent. They're reciprocals. They multiply to 1, right? Tangent times cotangent equal 1. So that's why this is going to work here. If you multiply by tangent over tangent, and then actually expand it on the bottom, think about what you're going to get here. If you expand it on the bottom, so let's write the bottom of this fraction first here. The bottom you have tangent times cotangent. What does that give me? It's just 1, right? Tangent times cotangent is 1. And tangent times 1 is tangent. That's what you have on the bottom there. Why do I keep saying that? On the top, actually, I'm going to leave it as is. I'm not even going to expand it. Maybe some of you did expand it and then factored it again later. Let's make a note over here. Tangent times cotangent is 1. That's what's happening here with that. Okay, tangent times cotangent is 1. What happens with this now, though? I have this on the bottom. I have this whole thing here, and I have this whole thing. What does that equal? Just tangent, right? So it's kind of a quick way of doing it. There's lots of different ways to do all these different things. Don't just learn and say, well, I'm going to do it this way all the time. Depends. You should look at different ways and see why they work. Okay? There's different ways to do this one. You can try different things and see. You might even try a couple different ways. Some of you already tried this. I do want to leave this for now and introduce you to the next one, but then you can have the time to work on all of these things today. Okay?